If you paid attention in school, which you probably didn't because you were too busy paying for lunch, you would remember that there are four states of matter. Well, you were wrong. This is a glass of water. It's a liquid, meaning it lacks a definite shape but has a definite volume. If I freeze it, it becomes ice, which is a solid, and solids have a definite shape and volume. And if I boil it, it becomes water vapor, which is a gas which has no definite shape or volume. And if you are a real science geek in elementary school, you would know about plasma, which is a gas that is superheated to the point where it is ionized, meaning it gains or loses electrons. The molecules are unstable and it behaves very similarly to a gas. Okay, you should know all that. What's the point of this video then? Well, this is where science gets cool because there aren't four states of matter. It's like saying there are only four Avengers when there are like 70 of them. Speaking of the Avengers, Spider-Man may be able to climb walls, but believe it or not, we've seen liquid climb walls in a state of superfluidity in which liquids flow with zero viscosity. One example of superfluidity is liquid helium, which remains a liquid at absolute zero, the coldest anything can possibly get. Speaking of absolute zero, 0 degrees Kelvin, well, what's it like down there? So cold, energy transfer no longer takes place. If you paid attention to my previous video in pentaquarks, which you probably never heard of, you would know about leptons and quarks. Didn't watch it? Don't worry, it's okay, but now we'll be talking about bosons. In the early 1920s, Albert Einstein and Satyendra Nath Bose predicted the discovery of particles called bosons. Think of it like this. Most of the particles you know of, which are made up of quarks, are like wooden planks. Bosons are the nails that hold the planks together with kinetic energy, which requires movement. But temperature is just a measure of movement, and that is where the fifth state of matter comes from. Near absolute zero, bosons clump together due to the lack of kinetic energy, and the substance, usually a gas, has its bosons act as, well, one gigantic superatom almost. This is the Bose-Einstein condensate. Confusing? This topic deserves a video all on its own, but just know that the Bose-Einstein condensate is the state of matter that happens when you get to absolute zero. But what's the opposite? Is there an absolute hot, and what does it look like? Let's go back to the Big Bang, the few minutes right after the origins of the universe. What matter existed right in these few moments? Scientists at CERN have confirmed that the state of matter at this time was quark-gluon plasma, or the, quote, littlest liquid. What's that? Well, quark-gluon plasma is a soup of, well, quarks and gluons. Quarks are the building blocks of the universe, and very simply, gluons are a very basic type of boson. It's basically the building blocks of matter, except they haven't been built to form anything yet. It's not a gas, plasma, liquid, solid, or Bose-Einstein condensate. It's a whole new state of matter. There's one last trip we have to make, and that's inside a neutron star, one of the densest, if not the densest object in the universe. When a star collapses, it often forms a neutron star, which can have a radius of only 13 kilometers and still have 3 times the density of the Sun. That's incredible density, far denser than anything we can possibly imagine. In fact, it's so dense that electrons are practically pushed out of their orbits. Electrons are no longer bound to their atoms. What's left are the protons and neutrons, and since electrons are practically massless and orbit at a gigantic distance away from the center of an atom, we're left with the incredibly dense nucleus. This is where the physics gets a little complicated but fascinating. The leftover matter, which we call degenerate matter, is not any known state of matter. It's super dense, so when the protons and neutrons move, there are no electrons bound to them. What happens is sort of what happens in a Bose-Einstein condensate. The matter begins to behave as one gigantic superatom, a single quantum system. Confusing, right? Science is supposed to be confusing. So, let's recap. The state of matter with the highest energy level is quark-gluon plasma, and when it cools to form atoms, it becomes plasma, which is the most common state of matter. Plasma can cool into gas, which condenses into liquid, which freezes into solid, and at absolute zero it becomes a Bose-Einstein condensate, and under extreme pressures it becomes degenerate matter. So now you can disprove your teacher by saying that there are, in fact, 7 states of matter. But at the rate that science is going right now, the number is only bound to increase. Thanks for watching.